Hi guys! A couple of weeks ago we did a live stream where we talked about how to use databases with Python, and now we've edited that video and got it all prepped for you to watch without all that live interaction and so forth, so you can go through it a bit quicker, and that is this video. So we're going to be going through a quick SQL primer, and then we're going to build the app here with you. So if you have any comments or any questions throughout the video, pop them down in the comments below and I'll make sure to keep an eye on those to help you out if you need it. All right, let's get started. This is going to be a quick presentation about SQL, just the main points, so that we can, get started with the Python coding. At its core, SQL is a language used to interact with databases. So therefore, we need a database. The database we're going to be using through this project is one called SQLite. And it is a perfectly functional database, but it is a light version of a full-blown database system. Some full-blown database systems you may know are MySQL, for example, or Postgres. SQLite is like a light version, very usable, very fast, but it does have a couple of limitations. At its core, databases are composed of tables. So what we're going to be building in this project is a coffee app. We're going to keep track of coffee beans. We're going to keep track of the way that we've made the coffee with a percolator, with an espresso machine or filter, etc. And then we're also going to give them ratings to show, whether we liked a specific bean prepared with a specific method. And so here, for example, in this sample table, we've got this bean, Awesome Arabica, that we made with an espresso machine, and we gave it a 90 out of 100. Similarly, the exclusive blend bean, whatever that might be, we prepared with a filter, and we gave it a 65 out of 100. So what we've got here is essentially the beans that we've bought and how we prepare them and how much we like them. Later on, we can use this data to make better informed purchasing decisions when we are browsing Amazon. And so what we've got in a table is, first of all, the column names. So every column in a table has a name. In this case, the name is name, but this column's name is method, this column's name is rating, this column's name is ID. And the tables are composed of columns and also of rows. So every row of data is essentially a bean in this table, and it contains information about the bean's identifier, the ID, the bean's name, the bean's method of preparation, and the rating we've given it. And as well as rows and columns, the combination or the intersection of both is a cell. So nothing new here, you guys probably know what a table is, but just a quick recap. So let's take a look at how we can create this table using SQL. So we're going to use a query like this one to create our beans table. And if we run this query, and I'll show you where to run it and how to run it in just a moment when we get started coding, that's going to create a table like this without data. So you've got the columns defined there, but no data in the table. And let's go through this query, how it's constructed. The first part is create table. That's something we put at the beginning. It tells the database that we want to create a table. And then we've got the table name. I'm going to skip over the if not exists for a moment because it's optional. So we've got create table, then the table name, and that is going to create a new table in our database with that name. And finally, at the end, we've got the column names and data types. So here you can see that we've got comma separated pieces of text. I'm going to go into what those are in a moment, but there's essentially 4 comma separated bits: ID, name, method, and rating, and that's why we end up with 4 columns. This bit here is necessary so that we don't crash the database if we try to create a table that already exists. So create table if not exists is used to prevent that error. Okay, let's go into the data types and the columns. Integer is used to define that the column will only contain rows where the cells are whole numbers. And text is for basically anything else, so characters, numbers, symbols, etc., whatever you want. The primary key here does have a lot of special meaning, and we go into what all that meaning is and how it's used in our Python and Postgres course. But essentially what it does in SQLite is it makes the whole number auto-incrementing. So whenever we insert a new row into this table, the ID column is going to get 1 more than the previous row. So if you have one bean with ID 1 and you try to insert a new one, then the ID will be 2. That's what auto-incrementing means. So this is a quick primer on create table. And now we're looking into how to insert data into the database, or into that table, really. You can do it like this: insert into beans, which is the table name, and then we say values, and inside brackets we put in a value for each column. So here we are inserting the number 1 into the ID column, exclusive blend as a string with the single quotation marks as the name of the bean, percolator again as a string with the quotation marks in the method, 65 in the rating. So here we would have bought this exclusive blend bean, we made it with a percolator, and we gave it a 65 out of 100 because it wasn't very good. But the ID is auto-incrementing as we defined just a moment ago, so we don't actually have to pass in a value to this. What we can do instead is we can say insert into beans, and then inside brackets we can put in the columns that we want to add data for. So that's the name column, the method column, and the rating column. And then after values, we simply pass values for those. And remember, we don't have the 1 here because it's not necessary anymore. That's going to get automatically generated by the database. So here's the next thing. We're going to select data from the database, or retrieve it, or find data. At its core, we've got something like select star or asterisk from beans. Here we are passing the columns that we want to retrieve. The star means all the columns. So if we run this on our test database here, we would get everything back, all the columns and all the rows. But the star here just means all the columns. So we're getting the ID, name, method, and rating. Instead of star, we can pass in specific column names, such as name, method, and rating, and then we don't get the ID column back, if that's what we were interested in. We can also sort the output, because you can see here that these beans are ordered by the order in which we entered them into the database, which is not a terribly useful one. So what we can do instead is we can order them by the rating. So now what I'm going to do is I'm going to put the 90 first, then followed by 85, 75, 65, and 5 at the end. So we're going to order them by rating in descending order. So that's what we do here. Select the columns from the table, order by which column we want to order by, and then DESC for descending order. And that's going to put the highest ones at the top, and then they go down. ASC for ascending is the opposite, and you can use that to go the other way around. Now let's try one more thing. We're going to select the method and the rating, so without the name of the bean, just the method and rating. From the beans table, we're going to order by the rating in descending order, but now we're going to add limit 1. And adding this at the end means we're only going to get 1 row back. And what this tells us here is that the method that produced the best output, regardless of the bean, was an espresso machine in this case. So that's some interesting piece of information. If you wanted to see, which type of method produced the best output, you can run a query like this one, and that lets you see that. Okay, so a bit of information here about ordering and selecting. The where clause in SQL is used for filtering. So before we retrieve all the rows from the database, we can apply some filtering with the where clause. So here we're doing select star from beans, which gives us everything from the beans table, but we're adding a where clause and say where name equal, and then we pass in a particular value that the name column cells should be exactly equal to. And this is going to return the bean with that name, as well as every other column, because we're selecting star, which gives us all the columns. So let's make use of everything that we've learned so far to construct a more interesting query. Let's say that we've got this test data. You can see that we've got exclusive blend bean in 3 different methods. So exclusive blend with a percolator, with an espresso machine, and with a filter, and they have different ratings. And then we've also got a couple other beans in here as well. What we're going to do is we're going to select everything from the beans, but we're only going to retrieve the exclusive blend bean. So these 3 rows, 1, 2, and 5. Then we're going to order them by their rating, and we're going to find which method was best for this bean. So what we can do is select star from beans to get everything. We're going to filter with a where clause using the bean's name. Then we're going to order by the rating in descending order, and we're going to use a limit 1 to get the best. And eventually that gives us this output here. For the exclusive blend bean, the percolator was the best method. So here's everything we've learned so far. We're going to learn one more thing about SQL in this lecture because we'll need it to draw our charts later on. So that is the group by clause. Let's say that we've got that test data again. Again, same stuff, 3 beans that are identical, percolator, espresso, and filter. And also we've got another bean using the espresso and another bean using the percolator. And now what we're going to do is we're going to select the method only. So that's only this column here from the beans table, and we're going to add a group by method. What this is going to do is it's going to give us only the method column, but it's going to add something hidden behind the scenes. So this is what we'll get. but every row here is unique to essentially the same type in this column. So you can see we've got 2 beans that use espresso, but because we've grouped by method, they get compressed into one row of output. But behind the scenes, hidden, is the groups that make it up, or essentially what things use that grouping mechanism. And so hidden behind the scenes, not available to us in the output, is this set of groups. And for the percolator, we've got the same stuff. We've got the 2 beans that use the percolator, and for the filter, we've got the 1 bean that uses the filter. So, like I said, this stuff here, all of these groups are hidden. And the only output where we get from this query is this table here, espresso, percolator, and filter. Not terribly useful. But when we have these groups available to us, we can use something called an aggregate function to access data in aggregate from these groups. So we can do something like select method, comma, avg of rating. This is a function, and we'll do much more on this in the course, but just a quick bit of information here. We can do avg of rating, and that is going to calculate the average of the ratings in each group. And because we've got the group by method here. So at the end of the day, what we get is something like this. The method, and for each method, the average rating out of all the sub-rows that we've got in the group. So these here, the avg, there's another one called sum, there's another one called count. They are aggregate functions, and they allow us to operate on the groups that would normally be hidden. Notice that if you select method, comma, name, for example, without using an aggregate function from the beans table group by method, you would be trying to select the method and also the name. But you can see that the name is not unique, essentially. It's there's 2 different names in the subgroup. So if you were to select the method and the name, SQL doesn't know which name to give you because these 2 are hidden away behind the scenes. That's why we have to use aggregate functions to access the data in these groups, and we can't access them directly. It's the same thing if you use method, comma, rating. It wouldn't know whether to give you 80 or 90. But if you ask for the average rating, then it knows to calculate it using all the data available. So that was a quick SQL primer. We've looked at how to create tables. We've looked at how to insert data, how to select data. And as part of the select, we looked at ordering and limiting. And then we also looked at where clause to filter and group by to access these subgroups in a main grouping. So hopefully that makes sense. Now we can start with our Python coding. So let's start with our app. Our app is going to allow users to add beans to their table of beans, as well as interact with the beans in various ways. See them, find a bean by name, see which preparation method is best for a specific type of bean, and so on. So we're going to start with a new file here that I'm going to call database.py. So what we're going to do here in database.py is we're going to start off with actually connecting to our database. And I mentioned we're going to use SQLite, and in Python, you can use SQLite 3. So we're going to import SQLite 3. This is a built-in module in Python that you can use. You don't have to install anything or anything like that. And this is what we're going to use to connect to our database. So now that we've got SQLite 3 imported, we're going to create our database. Remember, inside a database, we've got tables, and we've learned how to create tables using SQL with the create table command. Now we're going to create the database first. With SQLite 3 though, it's really easy to create a database. All we have to do is say something like connection equal SQLite3.connect, and then we pass in a file like data.db. SQLite 3 works from data files. And so whenever we connect to a data file, if it doesn't exist already, you can see I don't have a data.db file, then this is going to create that, is going to make sure that this is a valid SQLite database. Once we've got that, we can go ahead and execute our query to create our table. So the first thing we have to do is say with connection. And what this is going to ensure is that when we have executed our query to create the table, that it actually gets saved to the file. That's what this context manager does. Now that we've got with connection, we can go ahead and do connection.execute. And we put in here our create table beans, and then the columns and the data types. So that's ID integer primary key. that is name text, that is method text, and that is rating integer. So this is getting a little bit long here, so I'm going to just break it down into 3 lines. This is totally fine in Python, and this is going to make sure that our table gets created. So let's just run this file in PyCharm, which is what I'm using here. You can right-click and run it, and that's it, and you get data.db here on the left. If you try to open this, it's going to ask you what you want to open it with because it doesn't really know how to open it. If you open it as text, you're going to see some weird stuff in here, so don't do that. You can only access the data.db file by using SQL commands. If you have PyCharm Professional Edition, then you can use the database viewer in PyCharm to access it, but here I'm using the free edition, so we can't access it with that. All right, so now that we've got this here, I'm going to create a couple of functions to execute these lines, just so it's a little bit easier to use these from elsewhere in our application. So I'm going to create a connect function for this piece of code there that gets the connection, and instead of assigning it to a variable, I'm just going to return it. And that way, whoever calls this connect function can get the connection. And then obviously here, we can't call this because we don't have a connection variable, so I'm going to put this into another function as well called create tables, and this is going to go in there. We still don't have access to connection, so this is going to be a parameter. Whoever calls create tables is going to give it the connection that it has to use in order to execute the query. Okay. So that brings me to the next file. We're going to create a new file called app.py, and here we're going to interact with database.py. So this is something that we do a lot in this new course. We try to differentiate between user-facing code, code that users interact with, which is what app.py is going to use, and data interacting code, code that interacts only with the database. So this is what that's for. App.py is for user code. So what we're going to do here is we're going to create a menu function, and in it we're going to start by grabbing the connection. So we'll do database.connect, and we do of course have to import database. And then we're going to do database.createTables connection. The rest of this menu here is going to be asking the user questions, getting their input back, adding beans, finding beans, displaying information, and so on. Okay, so let's go back into database.py, and we're going to add our queries to interact with our database. So the first thing that we're going to start with is a good practice, which is to put our queries somewhere that is not inside the code. So we're going to grab this query here for create table beans, and we're going to cut it, and we're going to put it in here, create beans table, and we're just going to make it equal to that. I know it's a bit long here, so I'm going to shrink this there so you guys can see it. But now we can bring it down here and use it there. Having our queries all at the top is going to make it a little bit easier for us to change them later on when we need to. And so the next thing is insert bean. We need to be able to add beans to the database using the user's input. So we'll do insert into beans, and here we want to insert data into the name, method, and rating columns, but not into the ID column because that's automatically generated by the auto-incrementing functionality in SQLite. So we'll do name, method, rating, and then values, and we want the user to be able to give this query information or variables from the Python code. And so instead of putting what we want to insert here as we did before, we're going to put question mark, question mark, question mark. And then when we execute this query, we'll make sure to give the query 3 question mark variables there to be replaced into here. So everything that we write to interact with SQLite is going to follow this same structure. We're going to first use this context manager to make sure that whatever it is that we save into the database is actually saved to the file. And then we're going to do connection.execute, and we're going to run the query. So we're going to do the same thing here for add bean, we're going to call it. This function is going to receive from the user 3 things: the name, the method, and the rating. And then it's going to do with connection, connection.execute, insert bean. Just like that. Of course, it doesn't have a connection because that was a parameter here and it's not shared between everything. So it also does need a connection as well. Remember that we do have to pass in the 3 values that the user wants to insert into the query to replace each of the question marks. So that is a second argument to connection.execute when working with SQLite. We pass in name, method, and rating as a tuple of values that we want to insert. Each one will replace one of these question marks, and at the end, we'll be inserting into beans whatever the user wanted to insert. Now let's work on a couple other queries that we'll need to get the beans, find a bean by name, or find the best preparation method for a bean. So I'm going to do get all beans there, and this is going to be select star from beans. And by the way, I'm accustomed to writing uppercase keywords in SQL, but you don't have to. You can use lowercase if you prefer. I just think it's a bit easier to distinguish between what's SQL keywords, like insert, into, and select and stuff, from my stuff. Now let's find the beans by name. And that is going to be select star from beans, but where the name is equal to a question mark. And the question mark is, again, something that's going to be coming from the user. So let's write that function as well. We will find here the get all beans, and that is going to grab a connection, and it is simply going to do with connection.execute, execute get all beans, and get beans by name will do get beans by name, connection and name, and again with connection.execute get beans by name. So something that you may have noticed is that these queries here, create table and insert bean, are adding things to our database, but they're not really getting anything back, right? However, get all beans and get beans by name do get things back. And by the way, we have to pass in the name here as well. Remember, this has to be a tuple of values, so that's why I'm writing it like this. And so these here are getting something back. But these functions are not returning anything because, as you know, Python functions have to return something, otherwise they return none by default. And so these functions are not returning anything. So we have to change that. What we're going to do is we're going to do connection.execute, and then at the end we'll do fetch all. And that is going to give us essentially a list of rows that were returned by the database. And so we're going to do return of that. Similarly here, return of this fetch all, just like that. Okay. Now the next query that we're going to write is going to be one to get the best preparation method for a specific bean. So we're going to do get best preparation for bean. And this is going to be a multi-line string because it's going to be pretty long. And we're going to do select star from beans. We're going to add a where clause. We're going to add an order by rating in descending order. And we're going to add a limit 1. This is something that we saw earlier on in the presentation. It allows us to get everything from the beans table, filtering by name. Potentially this returns multiple rows if there's many beans that have the same name and different preparation method. We're going to order by rating to get the top preparation method first. Limit 1 is going to give us just that one row. So we're going to do the same thing here for getting the best preparation by bean. So get best preparation for bean, connection and name. And again, we're going to do the same thing here. We're going to pass in the name that we need. But now we're going to do fetch 1 instead. Fetch all is used to get a list of results back, but get best preparation for bean is only returning one row. That's why we do fetch 1 instead. And just to recap, select star is going to get all the columns from the table. So when we do select star where name is whatever, limit 1, we're going to get one row of data, but we're going to get all the columns in the table. If we did select name, for example, from beans, then this would only get the name column of the bean, which is not ideal since we wouldn't know what actual method that is. So let's go over to app.py. And we've got our menu here that at the moment doesn't really do anything. So we're going to change that. The first thing that we're going to do is we're going to add a prompt. So the first thing we're going to do is we're going to define the menu prompt. And this is going to be, again, a multi-line string that we're going to show every time that we want to ask the user what they want to do. And we might show them, do you want to add a new bean? Do you want to see all your beans? Do you want to find the best preparation method for a bean, etc.? And so the prompt here is going to be something like this. Okay. We're going to ask them to choose one of these options. 1, to add a new bean. 2, to see all the beans. 3, to find a bean by name. Or 4, to see which preparation method is best for a bean. 5, to exit. And we're going to ask them for their selection, just like that. There we go. So this is something that we're going to show every time we ask the user something. So let's start by asking the user stuff. We'll do while the user input, which should be equal to the input of menu prompt, is not equal to 5, then we're going to essentially have the user's input as 1, 2, 3, or 4. Okay, so we'll print user input in here. Now let me just quickly run this. Oh, I didn't run the menu function, so we do have to run that just to verify that this all works. The table beans already exists, so we have to go back to our database.py and if not exists. Make sure to add that in so that if we run this multiple times, we're not going to run into problems. Let me run that again. And here we've got our input. So this is the menu that we just wrote. It asks us to choose one of the options, and we can enter, for example, 1, and then it prints out our input, since that is what we told it to do. If you guys are not familiar with the walrus operator that I'm using here, it is used to give this variable, which is a new variable, this value within a statement. So we are evaluating this first, seeing what the user entered, and then we're checking that it's not equal to 5, and if it's not equal to 5, then we're running this loop. Every time the loop runs, this runs again, so we ask the user over and over until they enter 5. So now in this menu here, we are going to use a big if statement, basically. We're going to do if they entered 1, then we're going to add a new bean. If they enter 2, then we're going to see the beans, and so on. So we'll do if user input is equal to 1, and I'm going to put pass in here because we're going to add some code in here later. Elif user input is equal to 2, then we'll pass. Elif user input is equal to 3, then we'll pass. And if user input is equal to 4, then we'll pass. Else it's not 1, 2, 3, or 4, and it's also not 5, because otherwise we wouldn't be running this loop. Then we will print something like invalid input, please try again. Okay, so let's run this, see if that all works. If we enter 1, nothing happens. 2, nothing happens. 3, nothing happens. 4, nothing happens. 6, we get invalid input, please try again. And if we enter 5, then we terminate the application. So this is all working for now, which is awesome. All right, let's fill in what we want to do in each of these branches then. Since we've got the overall structure for our application, we now can go ahead and actually, add a bean here. So how we're going to do that is we want to ask the user for the information they want to add. So we'll do something like name is enter bean name, and then the method of preparation, we'll ask them to enter how you've prepared it. By the way, I understand that if you guys are not coffee fans, this is not all that exciting for you, but hopefully it's okay. And finally, the rating is going to be the int of the input. So we're going to take the user's input and we're going to turn it into an integer, and we're going to put that into that variable. Enter your rating score between 0 and 100. And then at the end, we're going to do database.addBean, since we've got that already in the database. And then we'll do essentially the connection that we created up here to create our tables. And we'll pass in the name, method, and rating. Now, this is all well and good, and we could run this code right now and test it out, but we can't actually see the stuff in the database. So I'm also going to add branch number 2 to display everything in the database. And so what we have to do is grab the beans from database.getAllBeans, pass in the connection that we created earlier on, and then for bean in beans, remember beans is a list. So here we're using the for loop to iterate over them. We simply print the stuff out. So we can just do print bean for now. We don't need a semicolon. So let me run this. We can add a new bean, and now we can enter the bean name. Let's say awesome bean 1. And we prepared it with an espresso machine. And the rating, let's say it was 50. It was not very awesome. So that's everything that happened in that branch of the if statement. The program is still running, but we've ran all of this stuff. And now all the other code does not run because it doesn't belong to this if statement. So we go back to the top and we ask the user again for what they want to do. This has executed. So we've, in theory, added the bean to the database. Now we can go ahead and type 2 to see the bean output. So we're going to type 2 in here, and you can see that we get that. So 1 is the ID of the bean. That is coming back from the database. This is the name of the bean. This is the preparation method, and that's the rating. So as you can see, SQLite gives us a tuple of values for each element. So what we get back from the database when we do fetch all is a list of tuples. Okay, so I'm going to stop that and contract it there again, and we can continue. Instead of print bean, what I'm going to do is I'm going to print an F string here with the bean name. So we're going to do bean1, which is the bean name, and we're going to say how we prepared it, which is bean2, and then we're going to say bean3 out of 100, just to give a bit more information as to what's going on. Let's take a look at 3. We're going to be able to find a bean by name. So what we have to do here is we want to find the name that the user wants to find in the database. And then we're going to run get beans by name. We pass in the name, and that is going to run the get beans by name query, which is here, which is going to select everything from the database where the name is equal to what the user entered. So you can see that by building data first, which is what we've done, we then have a very easy time building this user interface. So what we'll do here is name, and we're going to ask for enter bean name to find, for example. And then we'll grab the beans from the database. We say get beans by name. We pass in the name and the connection, of course. And then we do exactly the same thing that we did here. So for now, I'm going to copy and paste this. You might want to create a function for this, as we'll do in just a moment. But for now, we do that. Now, if we run the app again, and we type 3, we can find awesome bean 1, and that is going to give us awesome bean 1. We prepared it with an espresso machine, and it gets 50 out of 100. All right, let's go on to number 4. See which preparation method is best for a bean. Again, what we have to do is go into database.py, look at the query that we want to run. It needs a bean name, and it's going to select multiple beans. Well, one bean here. So what we'll do is we'll grab the bean name from the user, we'll then use that to run the query, and then we'll print out the best method. Okay, so we can do name is input, enter bean name to find, and then we'll say that the best method is database.get best preparation for bean. We pass in the connection and the name, and then we'll simply say something like the best preparation method for name, which is the stuff that the user typed, is, and then we'll write in here best method 2. Remember, best method is grabbing everything from the beans table, all the columns, and therefore is going to give back ID, name, method, and rating. ID will be column 0, name will be column 1, method will be column 2, and rating will be column 3. So that's why we're printing method 2 here to give us the actual method name. So let's run this. I'm going to stop and rerun that. We're going to do 4, which preparation method is best for a bean, and we'll do awesome bean 1. And it obviously says the best preparation method is espresso, because that's the only one that exists at the moment, but you could have other ones as well, of course. So here we've got this. The next natural step in this application development would be to put these into functions. So I'm just going to do that really quickly. In fact, I'm going to do that so quickly that you guys aren't even going to see what happened. There we go. And so what I've done here is I've essentially created a function for each branch. It does exactly the same thing that we are doing in the branches as to add a new bean. I've called the function prompt add new bean, and it just asks for the information and then calls the database. Prompt see all beans gets the beans from the database and then displays them. Prompt find bean does the same thing that we had before, and prompt find best method as well. Now all we have to do is go ahead and call these functions instead. So these need the connection as well. Okay, so hopefully that's not too confusing, but I didn't want to waste too much of you guys' time. So that's why I went ahead with that. But this code is all going to be available afterwards, so don't feel free to copy it. But what we've got here in the end is a pretty nice, simple way of creating an application that uses a database. We've got a simple user menu, and it calls other functions, each one of which then does something with a user and interacts with the database in some way. So what we've got up to now is database.py, which contains our queries and our database interaction functions. As this gets longer and longer, you might want to stop calling it database.py and start distributing the file into multiple files, one per thing that you're interacting with. So here we're only interacting with beans, but if you were interacting with beans in one table, with preparation methods in another table, with potentially users that consumed certain beans in another table, you might start to split this into multiple files. We've got these functions here, and they interact with the database in the way that our application requires. The benefit of doing this is that we can basically put any query we want here, and we can rely on the database to do the heavy lifting. So instead of just selecting everything from the beans table and then filtering it with Python, we can do the filtering and the ordering and everything with the database, which is much faster. And we can simply call a function to do that for us. In app.py, we've got our branches here for our interaction and different functions to do that. And that's about everything you need to build an app that uses a database with Python. If you were here during the live stream, you remember that we try to continue, and the next part of this video is about using matplotlib to draw graphs and charts using Python. But in the live stream, we lost the internet, so we couldn't continue. But that video is linked up at the top left as well as in the end of this video and in the description below. So if you want to learn how to use graphs and charts with Python, do check that video out. It talks about the same database, and we go through how to build the graphs and charts there. So thank you guys for joining me in this video. Thanks so much for watching, and I'll see you in the next one.